when do you use volume? When do you use surface area? Okay. So volume, remember, is always measured the space inside. Okay. It's always how much can fill it, how much you can put in there. Okay. Includes only space needed to fill and is measured in cubic units. So remember, that's always with the 3. Okay. Surface area measures the outside of the surface. It includes every single face. So remember, we always have to look at the shape and say, does this have 5 faces? Does it have 6 faces? How many faces are there? It's always measured in square units because it's a flat shape. All of them are flat. And can be measured using a net, which is how I taught you from the beginning. Remember, we cut out the little nets and made our shapes. Okay? You can't use a net to find the volume. That's the point. Okay? And they're both a way to measure 3-dimensional objects. So both of these are used. That's how they're kind of the same. Okay, so just remember, volume is to fill up. Surface area is if you're covering it all the way around. Okay? All right, so let's look at our first problem. All right, so this one says, Vincent put logs in the shape of a rectangular prism. He built his rectangular prism out of logs outside of his house. However, it is supposed to snow, and Vincent wants to buy a cover so the logs will stay dry. If the pile of logs creates a rectangular prism with these measurements, what is the minimum amount of material needed to make a cover for the wood pile? Okay, so let's start off here. This is a rectangular prism. I'm going to go ahead and start off by drawing it so we can kind of see what it's talking about. Okay, so here's our rectangular prism. Remember, you start off like that. If I'm drawing this, should you be drawing this? Yes, there you go. Very good. All right, so this would be 33, 12, and 48 high. So it looks something like that. And imagine it's logs, so he stacked logs in there, but that's the shape that the logs make. Okay? All right, so let's start off by talking about the dimensions of each of the faces. First of all, how many faces does a rectangular prism have? 6. Always has 6, right? Okay, but think about what he's talking about. So he wants to cover the rectangular prism because it's going to snow. How many faces does he need material to cover? I heard some people say 5, some people say 6. What, Mario? Say it loud. 5 because you do know. You know why. He's saying 5. Why don't you need 6? Say it.
Because the other side is on the ground.
Very good. He didn't say that he wanted to cover the ground, and some people do like to cover the ground if they have wood out there. Okay, so he only wants the 5 faces. Does that make sense? Okay, are we talking about a volume or area? Sorry, volume. Yeah, volume or surface area.
Surface area.
Why?
Because you're not going inside the thing.
Not going inside the thing. The wood would be the volume, right? The surface area is because we want to cover it and protect it. Okay? All right, so let's look at the different sides here, faces that we need. We need this face here. What are the dimensions of that face?
35 by 48.
Good. So 33 by 48. How many of those sides do I have? 2. So I'm going to go ahead and put times 2. Okay. Let's see. What about this face here?
12 by 48.
Good. How many of those sides do I have? 2. Good. All right. And then let's see. I need this up here. 33 by 12. Good. And how many of those sides do I have? Just 1, right? Because I don't want the bottom. I only want the top. Okay, so at this point I can grab my calculator then. And say 33 times 48 times 2 is 3,168. And 12 times 2 is 24 times 48 is 1,152. And then I have 33 times 12 is 396. Okay? So let's add those together. So 396 plus 1152 plus 3168 gives me, oh, what did I do? I hit multiply on accident. 3168. Let me get it. Alright, Is that what you guys are getting? I don't want to hit something wrong. So 4,716. 4,716. And what was this in? Oh, well, no wonder that's so big. Why am I saying that? It's in centimeters. No one's going to buy something in centimeters. They're going to put it in like feet. You know what I'm saying? You know how small centimeters are. I think they're tiny. That would be kind of silly. And that's not a very tall wood pile either. That would be a pretty dinky small wood pile in centimeters. All right. Questions on that one? You feel like you understand that? Okay. Let's try that. We're not going to work all of these. We're just going to work a couple to make sure you know how to find the difference. Okay. Probably need to go over this one because this one's a little tricky. All right. So it says a packaging firm. Oh, I forgot to. Has been hired to create a box for baby blocks. The firm was hired because it could save money by creating a box using the least amount of material. The packaging firm knows that the volume of the box must be 18 cubic centimeters. What are the possible dimensions for the box if the volume must be exactly 18? What do you guys think? What are the possible dimensions for the box if the volume must be exactly 18? So hint would be, how do you find volume?
You have to take the
Base area times the height. So it's taking a number times a number times a number. Does that make sense?
So
Okay.
Something
Something times something has to give us 18. Cassie? Okay, so one of her thoughts is a 2 by 3. You said by 3? Okay, because 3 times 3 is 9, so 9 could be the base area, and then it could be too tall, and that would give you 18. Any other options? 18 by 1 by 1. That would give you a really long, skinny, narrow. So 1 by 1 by 18. That would give you a volume of 18. Lily?
6 by 3 by 1.
Okay. 1 by 3 by 6. Yes?
2 by 9 by 1.
Okay. 1 by 2 by 9. Are there any others? I think maybe we have them all. Can you think of? I can't think of any others. Okay, now if you were in charge of packaging, this doesn't go on to say that. How would you then figure out which one would take the least amount of packaging? What would packaging be? Surface area or volume? Surface area, because you have to make the package like out of cardboard. So how would you figure out which one would cost the least amount? And do what? What would you have to find? The surface area of each. The surface area of each one, right? Does that make sense? That's what companies do when they're developing packaging. That's what companies do. Were you guys around when Coke used to make? You know how now they make? I have one up there. The fridge packs, where it's like long and narrow. Did you know they didn't used to come like that? They used to come in big boxes, and then they came up with that. Why do you think they came up with that? Cheaper. It cost less. It had less surface area, and they could stack more on the shelf. So that was more volume. They could get more volume on the shelf, so that they didn't have to stock the shelves as much. All of that is a money issue. So anybody, my husband works for Coke, so that's why I know that. But all the time, that's what companies do. They're always figuring out this kind of stuff to save money. All right, let me try to find one that I think you might be able to handle. Kind of on your. Let's work part of this together, and then I'm going to call it good on this. All right, let's look at this one. It's the last slide. All right, this one says the bottom part of the block is a rectangular prism. The top part is a square pyramid. You want to cover the block entirely with paper. How much paper do you need? Walk me through what I would need to do. Is this volume or surface area? Surface area, right? Okay. Now tell me what I would need to do to calculate this. Kendall.
Would you have to find out the surface area of the square and then do the triangle?
And then do the triangles. Does that make sense? So how many faces here? Let's see. You want to cover the block entirely with paper. How many faces here were we covering?
9, 6, 9.
It's 9, right? Do you guys see how you would have on the rectangular prism, you have 1, 2, 3, 4 going around that way. You'd have 1 on the bottom, which would be 5. And then how many triangles do you have? 4. Does that make sense? Do you feel confident that you would be able to find the surface area of each piece? Yeah? What would you do after you got the surface area of each piece? You add them all together. Right? Is that confusing? If it is, you need to tell me. The triangle part? Okay, let's just do the triangle part. Let's do that part together. Okay, what would be the dimensions of the triangle? 6 by 4, right? Here's the 4. Here's the 4. Okay, so I would do 6 by 4, which is 24. And what do I have to do? Yep, divided by 2. So the area of the triangle is 12. How many 12s do I have? I have 4 of them. So I take this times 4 and I would get 48. Does that make sense? So now I just did the whole top. And then if I did around this way, could I do that? What's this face? 4 by 3. So that would make 12. How many of those do I have? 4. Technically on this one I do have 4 of them, right? Because this one is also a 4 by 3. So I would have 4 of them going around. So 12 times 4 again is 48. What's the bottom? So how much is that? 16. And add the 16 to it. Does that make sense? How you do those kind of weird shapes? Do you feel comfortable with that? That's what 4th and 5th are. Like after I watched you guys, then I told them, I said, let's break it down and draw them out, and they said the same thing, that they found that very helpful. Okay, I want to give you time to get started in class today, so I'm giving you 15 minutes. You have a worksheet that's due, so you can work on that in class. I would think you can finish it in class in 15 minutes. You also have digits 13-1 that I'm getting ready to put in the computer right now, and 13-2 I will probably put in the computer Monday afternoon, so make sure that all those things are done. Okay? All right.